But hey everybody, this is 7.3. We're doing dividing with exponents. It's called the quotient rule. Alright, so we want to figure out what happens if we are dividing like bases. So if we look at this example, one way we can figure what this is we could expand. This would be the same as x times x times x, 5 times for the numerator, and the bottom would be x times x times x. If we have x over x, those will just cancel, and we end up getting x times x, or x squared. Okay, so is there a relationship? How do 5 and 3 give us 2? So think about that for a second. Here's another example. Coefficients, what's in front, you just treat them like normal. So 2/4, that's the same as 1/2. So we can simplify 2/4. And then on the top we also have 5 x's and 2 x's. So here those cancel out, and we end up getting x to the third. So we'd get x to the third, or 1x to the third, over 2. All right, so again, how do we get 3 when we have a 5 and a 2? So here, hopefully you're coming up with the idea that whenever we divide like bases, we subtract their exponents. All right? So maybe we can write that here. When we divide like bases, we subtract their exponents. Okay? So if you have something like x to the a over x to the b, that's the same as x to the a minus b. Okay? But we can also do something like this. All right? So it doesn't matter, whatever one your first number, so like if we had b and we wanted to subtract a, then we're going to stay in the bottom where that belongs, okay? If we're going to do a minus b, then a is first, and that stays where it is, if that makes sense. We'll do some examples, see if that helps, okay? We could do more we can expand more here, but let's kind of look at this a little different way. The best way I think to remember is we're going to keep the larger exponent. So we're going to start, like in this example, we'll start with the 3, and we're going to subtract 2, okay, because we have 2. All right? So we'll do that. We can do it top to bottom, and it keeps it balanced. We haven't changed anything. But x to the 2 minus 2, that's just x to the 0, or that's just 1, right? So x to the 0 is 1. And on the bottom, we would end up getting x to the 1. So we get 1 over x to the 1. Let's try this one. Which exponent is larger? Just remember, if we're missing an exponent, it's just going to be a 1. So here, we'll keep the 3 and we'll subtract the 1. But again, when we are on the top, we'll get x to the 2. And on the bottom, the 2 is by itself. It doesn't have an exponent, so it will stay. And then x to the 1 minus 1, well, that's just x to the 0. And x to the 0 is just 1. So that would be 2 times 1, or just 2. Okay, so basically it just cancels out. All right, here's some other examples. 3 is the larger, so we'll do 3 minus 2. That just cancels out. And then I guess maybe first we should talk about the coefficient. So 6 divided by 2 is 3. And then here we have x to the 1, or just x. Here's another example. But we have y on top and x as our variable on the bottom. Those are not the same. So we can only use these rules if they have the same base. Okay, so that's why we wrote here, when we divide like bases, we subtract their exponents. Okay, so here's just some more examples. If you want, pause and give it a try. I think that would be a good idea. So again, when we're dividing, we subtract their exponents. I would recommend subtracting from the larger number, so 7 minus 3. And that is just x to the 0, which is 1. So it's just basically gone. And we end up getting x to the 4. All right, here is another example. We'll look at our coefficients first, so that's just a 2. And then we'll look at our x's. Again, we'll take the larger number and we'll subtract the smaller to top and bottom for both exponents. And we would end up getting x to the, oh sorry, it's on the bottom, x to the 4. And on the top, that would just cancel. That's x to the 0. All right, these ones are a little different because now we have 3 variables, 3 x's. If we have more than one on the top or the bottom, we're going to simplify the top first. In our last lesson, we talked about if we're multiplying like bases, we add their exponents. So that is x to the 8. Can we add them? And then we'll do what we just did. We'll subtract 3. That would cancel and give you a 1. And we end up getting x equals 5. All right. The thing about exponent rules, if we're simplifying, there's lots of different ways to do that. So just keep that in mind. The way I'm going over it doesn't mean that there's not another way to do it. Some people like to maybe take everything to the top, and if we did that, we would get x squared, x to the 6th, and if we bring it up, we'd change and make that be a -3. And now everything is being multiplied, which means we will just add all of those together, all of those exponents, which would end up giving us x to the 5. So you end up getting the same thing, but there's different ways to do it. All right? And then here's another example. So again, let's figure out what these are first. So that would give us 3x to the, again, we add their exponents if we're multiplying, so that's 6, all over 6 times x to the 7th. And then, well, what else could we do now? It looks like we could maybe simplify that. 3/6 is the same as 1/2. And then we'll take the bigger number and we'll subtract the smaller. So that's gone, and we would get x to the 1, or just x. Okay? So it looks like it's kind of scary. It's a big number. We have lots of variables, lots of exponents. Break it into chunks, okay? But always simplify the numerator first, and then the denominator, and then we can look at the fraction, okay? All right, here's just 2 more examples. Pause and give those a try if you can. So that can be simplified. 9 over 3 is just 3, right? And then again, we'll take our bigger and we'll subtract the smaller. So subtract a -2, which will end up giving us a +2, plus 2. So that would give us x to the 7th, okay? And then last, like this, again, we'll simplify the numerator, but that's an x and that's a y, so those can't be like combined, same as the bottom. So now we'll do our fraction. So that looks like -4 divided by -2 is a +2. Okay, here's our bigger number, so we'll subtract the smaller, so this would be like a 1, so -1. That just is gone, that's just a 1. And we'd get x. And we'll do the same for the bottom. This is like a y to the 1. So we'll subtract the smaller from both of them. And then we'd end up getting y, not there, because this is just 1. So we just have what's on the bottom, y squared. Okay? All right? I mean, if you kind of think about it, I mean, I think as you go along, you'll probably get this faster and faster. But, I mean, like this, I think we got that. That was just 2. Here we have 2 on the top and 1 on the bottom. So it looks like we could take 1 from top and bottom. So that would give us an x on the top. And then we have 1 on top and 3 on the bottom, so it looks like we could take 1 from the top and the bottom, so that leaves us with y2 on the bottom. So if you kind of think of it that way too, that might be helpful. All right, last thing is, remember the area is length times width. And here it says, what is the length of the missing side? Okay, I guess in this one is, what is the width of the missing side? But anyways, so we basically know the area. The area is 30 x to the 10th equals length. Length is 6x to the 8th times width. And if you want to get width by itself, all we'd do is we would divide both sides by 6x to the 8th. Okay. Another way you could do it is we want w by itself here. We could just divide both sides by L. If it helps, you could say that width is equal to area divided by length. And then you can just plug stuff in. All right, so we end up getting this. It looks like a problem similar that we've done already. We just need to simplify, okay? So 30 divided by 6 is 5. And then we'll look at this. Again, larger minus smaller, so minus 8. And that would give us 1, basically cancel out, and we get x to the 2. And that would be our width, so 5x squared. All right, well that's it for today. Just remember, if we're dividing like bases, then we will subtract their exponents. It's useful if you choose to do the larger minus the smaller, okay? Let me give you an example of what would happen if you didn't. So maybe, where's one we got? I think it was like this one. So let's just look at this. This is like x to the 1 over x to the 5th. Okay, so if you decided to want to subtract 5 like this, there's nothing wrong with that. That would cancel, that would give us x to the 0 or just 1. But here we'd get x to the negative 4. And we don't want negative exponents, so you'd have to do one more step. You would need to bring it to the bottom. So here, this is like an exponent of, I guess for this is a 2. So the 2 would stay, and we'd bring down the x to the 4th. We end up getting the same thing, but I think it's easier if you do the larger minus the smaller, so that you don't have negative exponents, okay? Which is really nice not to have those. All right, well, we'll see you later.